have the opportunity to view it in the engagement community group. All right, the recording is on. So if your network comes back on, you let me know. Nevertheless, this will be shared in the group, so for everyone to follow up and know what is expected of them in the assignment. So as I was saying, this is the layout, the printed work of the layout, and this is everything that is in the layout, and you were asked to represent this in a circuit diagram. But first of all, the first thing that should come to your mind when you're okay, you can see it now. Beautiful, beautiful. The first thing you should, I'm recording it now, so I'm going to start a little bit. I'm going to go a little bit from the start so others can benefit. So the first thing that should come to your mind is where is the input current? Where is the input signal? All right. So if I can spot my incoming signal, and I will start from there to read the traces. So reading the traces will enable me to understand how the circuit can be repaired if a component was faulty, and will help me further to understand how the component works in a way that they are connected in the layout. So this my input rails, and I told you that if I find amp, this is amp in a circuit, if I find this particular label amp, it tells me that it is not just DC, it is not DC current, direct current that is coming at this point, the input point. It is alternating signal that is coming, because amplifier is just like the sound. Is the sound. Okay, so it's a signal, it's the alternating signal, just like the wave of a heartbeat. And I did the diagram here, the wave of a heartbeat, that can be seen. So at this point, the voice of the speaker, the voice coming out from whatever circuit representing the signal coming out from whatever circuit representing the voice of the person, maybe from a microphone, picking from there, it amplifies. So once a circuit amplifies the signal or the voice of the person, the signal coming out from the amplifier is what? Amplifier output. So this is the particular signal coming out from the amplifier output, and this is the circuit that wants to turn it into something else. All right, we don't know the name of this circuit. What we are asked to do is to analyze this circuit, is to represent this layout in a circuit diagram. But you can see it is a simple VU display LED. So now the amp, now this represents, at this point, it's just like the heart, the signal of a heartbeat. At this point, the voice of the speaker is louder, and at this point, the voice of the speaker is almost down. At this point, the voice of the speaker levels becomes average, and at this point, it's fluctuating. Okay, even at this point, that is kind of like becoming average. It's still fluctuating, but can't be seen by the signal generator. Okay, if only you can zoom in, you get something like this. It will not be a pure sine wave like from your main supply, but you get something similar to this. And I said that the upper part of this signal, remember this signal is separated by 0. This particular is 0. This is a graph. This is 0 volts, 0 volts. So the upper part here, the upper part of this signal is a positive half cycle, and the other side, the downward part, the downward slope is a negative half cycle. It's a negative half cycle. So this part is the positive half cycle. This part and this part is the negative half cycle. Here is the positive, here is the negative. All right. So that is the first thing you're supposed to know, and you will find out why you're supposed to know that. So moving from that, I said this is a symbol. You have to know, second thing you have to know is what are the symbols in the layout, and what are the components in the layout, and do I know the symbols for all the components in the layout? Let's quickly do that. Now, this shape, review the lesson video we posted. This is a shape of a resistor, nothing than a resistor. I'm bringing out a resistor now, and you can find this is the exact shape. All right. So the resistor, have you seen? Just look exactly the same. That means that is a resistor. All right. And I have resistor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 resistors here. And moving on to the next components, these are LEDs, light emitting diodes. Now, before I move on to light emitting diode, these are the symbols for resistor. Either you use this or you use this. They are all the same. Both the same. The only difference is that the first 1 year is adopted by IEC. So IEC is a commission, okay, in the industry. So all represents the symbol of a resistor. So the LED you're seeing here, this is a symbol of LED itself. So it's represented. So in circuit diagrams, if you see this particular symbol alone, know that it is not an LED, but a diode, but this particular diode. Now, if you see this symbol alone, this is a diode, a regular diode, and not an LED. Okay. If you What makes this symbol an LED is when the two arrows here comes on top. When the two arrows here come on top, telling you that it is emitting something, it is emitting light. Okay, this tells you that it is emitting light. So that is the name light emitting diode. It's a diode, but diode that emits light. That is why you have this on top. So just quickly know that this is an LED. And now, this is a capacitor, like I said. A capacitor, like I said. Okay. Here is the port. Why is it a capacitor? I can easily know it's a capacitor from the label here. I've seen 220 microfarad. This is a unit. Review the lesson on unit conversion to have an understanding of what we mean here. This is a unit, and farad is the unit of capacitance of a capacitor. A capacitor is a device that exhibits capacitance. Okay, capacitance is the ability of a capacitor to store electric energy. This capacitor here can store electric energy. We are going to do a very comprehensive analysis of capacitors, and we are going to do that in live practice. 400 volt means that you can store up to 400 volts. 100 microfarad, this is 220 microfarad. Now, how can I identify the positive and the negative side? Not all capacitors have positive and negative. If I find on a layout there is positive and there is negative, I quickly know that that is a polarized capacitor, an electrolytic capacitor. This is a polarized capacitor. Anything that is polarized have positive or negative, or they are divided into two sides. Okay, so how do I know the negative side and the positive side of this capacitor? This is the positive side right here, and how do I find it here? Now let's check the body of this capacitor. Have you seen? Okay, fine. You've seen this particular diagram, and you've seen the minus sign there. This minus sign indicates that the leg just next to it, this particular pin, is the negative side. Just next to this marking here, this cross marking here, this is the negative side, the negative side, the negative side, and this other side is the positive side. So once I want to install, I take note, the positive side goes here and the negative side goes here. Negative side is not usually often labeled, so you have to know what we're talking about. And other capacitors, you can have an exo through hole capacitor. There's also a farad marked on the body, so it comes with a capacitance value. So you have to understand the capacitors you need to use in circuits. Now the next, fine, this is a symbol of a capacitor. So when putting everything down here in a circuit diagram, don't draw the component out. You are drawing the symbols. For resistors, you choose either of this. For the LED, you choose either of this, and for the capacitor, you choose either of this. But wait, for a polarized capacitor, remember when you're choosing this is the British symbol and this is the American symbol. When you're choosing this, remember to identify that it's polarized. You put a plus there, and that is fine, just the plus. If you go ahead and put the if you go ahead to bring minus to these points, someone may confuse it to a battery, okay? Because batteries have this similar to this, but one um cross is one line is longer than the other, and this is plus, this minus. So this is a battery. We are not dealing with battery, we're dealing with capacitor. So just a plus and equal. This the parallel lines here must be equal. The parallel lines here must be equal. So if you're choosing this better, this is the positive. Here is always the negative. Remember, here is always the negative. So you find this in so many circuits. Here is always the negative. So there's only one component left. This is where the screw will come in. This is where the screw will come in. So you don't have to worry about that. You can see these are the traces. These are the traces. These are the traces that we talked about and we explained in our videos. So kindly review the videos to have a better understanding of what we mean here. So the last components here are the diodes. We have how many diodes? We have up to 12 diodes here. And I really want to talk about this. Please pay attention. How do I know it's a diode? A diode is the only component in my circuit or in a circuit that will have this symbol. How is the symbol? Please follow me. I'm going to be drawing another thing here, so I'll be managing this space for now. So I'll just cross follow me. How is the symbol? So this symbol, there is, okay, so this is my diode, and the circuit symbol for this is, now this particular shaded line is where I'll drop this one. Remember what we did here. This is a diode, so this is the shaded line, and this particular unshaded portion is the triangle standing just next to the line. Have you seen? So this represents this. This is this. This is this. If this is turned to this other direction, so that the shaded line, the shaded portion is this way. This also so this have to be turned to the same direction, so that this point will represent the shaded portion of the component. All right, I think I have a diode here. If I have a diode here, all right, I do have a diode here. So this is what I'm talking about. All right, so this is what I'm talking about. This is the shaded portion. I hope you can see this clearly. This is the shaded portion, and this is the portion not shaded. These are the shaded portions. We have 4 diodes here forming a bridge rectifier. We're going to analyze that particular circuit together, so you don't have anything to miss. Just stay around and keep your notifications on for videos to come this week. here it is. So that is it. Hope you understand that. So now I have explained every component that is here. But before I can proceed, there are markings on the body of the resistor and also markings on the body of the diodes. Now these markings will enable me to know the type of diode, the kind of diode that I will install on this PCB. I wouldn't just install, I won't just install any kind of diode that is available or that comes to my mind, and I won't just be installing any resistor that comes to my mind. I'll be following this marking, okay? This marking. So I'll have the correct voltage drop across this resistor that is you are to be entering this particular lane, and I have the right voltage at this point, across. So there will be a voltage drop here. Across there will be a voltage drop here because of the resistance here that you'll be entering this particular LED. So that is it. Quickly, we there's a lesson that analyzes this. Okay, when you say, for example, 180 that is here, you know that the first two digits are significant digits. That is one, and this one represents the power of of 1, so that is 10. So this is 180 ohms. This is 180 ohms resistor. And for the diodes, importantly, now 4148, you need to take note of the marking. The comprehensive table is available in the textbook for you to work on. So you need to know the kind of diode to buy and install on the PCB. Diodes with 4001 to around to specifically 4007 are rectifier diodes. This very diode, now there is always 1 and N. Okay, so this very diode is 1N. Don't forget that 4148. This very diode is called a switching diode. So this diode is not rectifying, it is switching. What does switching means? If current flows, you have a diode lesson, okay, practice lesson, live practice. If current flows from this across the resistor in this direction, the current is forward. The diode is forward biased. If current flows in this direction across the diode is reverse biased. A diode is a component that allows current to flow in only one direction. So that's to say, if this were to be a rectifier diode, current can only flow in this direction and cannot flow in this direction. Positive voltage can only flow in this direction and will not flow in this direction, while negative will flow in this direction and will not flow in this direction. That will be explained to you, but get the concept behind the operation of a diode right here. So this is a switching diode, means that it changes its polarity per time. It changes its polarity per time, just like your AC mains changes for a 50A power supply, changes its polarity, the positive half cycle and the negative half cycle 50 times in 1 second. Wow, 50 times in 1 second. So this very diode, switching diodes, and this very number that I know very well, changes its polarity from reverse to forward, forward to reverse, and vice versa in just 4. That is done in 4 nanoseconds. Super fast, in 4 nanoseconds. So this is a high switching diode. It's a high switching speed diode. Faster, and it can handle up to 100 volts. This very one that I know very well, it can handle up to 100 volts and a current of 0.2 amps. That's the power rating of this capacity of this diode, 0.2 amps. So the voltage drop across this diode will be whatever voltage is coming across this diode, just like the voltage coming across this resistor, voltage coming across this diode will be minus 0.7 volts. Okay, so that is to say that the forward voltage drop across any diode is always 0.7 volts. So if I have 5 volts coming in here, for example, at this point 5 plus 5 volts, because minus 5 volts cannot cross this diode, remember it will block if this were to be a rectifier diode. So 5 volts plus 5 volts coming in here, plus 5 volts coming in here, at this point it will be minus 0.7 volts. So that is the voltage. Without even using the multimeter, you can know the voltage that will be at this particular point. So now remember, this is alternating signal, so that is where we are using a switching diode. Now can you understand now? This is an alternating signal, that is why we are using a switching diode. We are not doing rectification. Rectification is for power supply, like this very circuit that was brought earlier. This diode is doing rectification. Okay, these diodes are doing rectification work, and this is a transformer power supply circuit. This is a transformer power supply work. If that is done and you analyze, you get that. So now back to, I'll do half of the drawing and you complete the other. Please pay attention as I do a walkthrough of from the traces, read traces, and do the drawing component to component. All right, let's keep it this way and let's see what we can do. All right, so first, I know my input. Since it is from an amplifier, I can do something like, I don't have to do the symbol of a direct current, or so it's often I can use this particular symbol. Okay, I can use this particular symbol here. This is a nice symbol, hope you can see, and I'll now say this is my GND, this is my ground. Okay, that means, that is to say, I'm now representing this other input here as this particular point, this one. Remember, this is not connected together. These are two inputs. So this is the symbol I'm using to represent this both rails. The first rail, this first rail is this one here, and this other rail is this one. They connected to the ground. So this is connecting to a floating ground. This is a floating ground. Have you seen the way it is? And if you really look it, and if you really look at the PCB, you get to know that it is really connected to a floating ground, because the negative side of the LED is connected to the GND. So have you seen how it works? The trace, yo, wow, this is it right here. So I have the connection here, and from there, now I'm leaving this part. Remember, this part is common to every circuit here, is common to every component here, so that is common. So I can just leave it as common as a reference point, and the reference point is the GND. So review our lesson to get to understand floating ground and what and other things you need to understand. All right, so from component to component, we'll be reading the trace. Now, at this point, let's see, it goes to two resistors, and across the resistors, it links to the negative side of the polarized capacitor, and the positive side of the polarized capacitor picks up to the diodes. And how can that be? I'll just do it in a technical way. It links to both resistors, okay. Have you seen this? You've seen this, right? Links to both resistors. So I can now say this is my R1 and this is my R2, and the other part links to this, the negative side, okay. This is the negative side now, and the other positive side links to a diode. So my positive side, okay, this will be my negative side. I'm using a polarized capacitor, and my positive side now, so I'll now represent this as plus, showing that I'm using a polarized capacitor just as the way this is. So this other side links to a diode, my D1. So how would that be? And the diode, take note, and the diode links to the GND, the GND rail. So I can now say the diode now. Which side of the diode? Is it the shaded side? The unshaded side links to the GND. So the unshaded side links to the GND. This is the unshaded side now. This is the unshaded side linking to G and D. So I continue. Remember, this is a continued trace to this particular. This is a continued trace. Pay attention. This is a continued trace. That's a continued trace to D2. So D2 picks up. Where does it pick up? The unshaded part. The unshaded part, call it anode, and the shaded part, call it cathode. That's the way it's called in the industry. So it links up to the anode, and then what happens? It links up to the anode. What happens from the anode? Okay, I have two linked traces. First linked traces is the one that goes to this diode. Remember, this is the trace. This is a trace to this diode from this D2. From D2, this is D1. Please take note. D1, D2. Okay, this is D2. From here, which is here, from here, across the diode, across D2. From here now, I have this trace, and this trace. This one here, moving straight to the capacitor that links to the GND. So how can that be drawn? How can that be drawn? It links to this and links to this. Two traces. It links to two traces, trace 1 and trace 2, that connects all the way to the capacitor. So trace 1 connects actually, and okay, let's do it this way. Let's do it this way quickly. Trace 1 connects to another diode, so, and there will be an extension for that. There will be an extension for that, and there's another connection here. This one that links to the capacitor that links straight, so I can bring that on that same trace. What's the capacitor? What's the connected to the positive? So then the positive is polarized G and D. All right, so that's how. So I've worked on this particular trace, the long trace here that connects to the capacitor here. So now there is this one that connects to the capacitor. Remember that same trace here that connects to this capacitor, and right from here to the LED here, to the anode side of the LED and the negative side connects to the ground. So that will be this way, G and D. And I won't forget to include my arrow to indicate that it is emitting, it is a emitting diode. Okay, so that is LED1, LED1. Okay, so I have gotten the trace here, the trace and the extension. All right, have you seen now that I've gotten this part? I've gotten this part, the one that connects to the resistor here, R1, R3. I mean, this is R1, R2, R3, R1, R2, R3, and then R3 connects to the LED as shown here. Have you seen the circuit looks very technical? Okay, so that is how it will be done gradually till R8. Okay, that's how it will be done, and to D12. That is how it will be done till LED, the last LED here, and you have a very nice circuit. So the extension goes, and then okay, let me just give you a hint. The extension, this is the extension now, this other extension to this another diode here, and the diode connects to this resistor. Two traces, the resistor here and this other resistor, it connects to this resistor, and here it connects here to the LED here, and then connects to this. So that is how it's done. So do something of this nature and make a summation. Remember, this is part of your grading, and would love to see wonderful work, beautiful work from all of you. Thank you for joining this session. I appreciate your time. Thank you for joining. Thank you.
Okay, this